Welcome back. Here we're going to do our experiment. We've got our power source, we have our resistor, we have the leads of the power source attached to these little wires here to make the measurements easier. We have our multimeter. We're going to flip this baby on and go through different levels of voltages and capture both the voltage across this resistor and the current running through the resistor. We'll begin by turning on our power switch. We can tell that it's on this particular circuit because the red light is there. So now we've got our DC power supply. Let's go ahead and measure the voltage across. So I'm going to turn my function dial to the small v. Whoa, it's almost like somebody spent a long time messing with these dials to capture 1 volt across. The first measurement that we have, measurement number 1, we're going to get 1 volt across this. So this is the positive, that's a negative. We have 1 volt across. Now we're going to capture the current data. So we're going to turn this off. We're going to break the circuit. So we want to put this in series, which means I'm going to capture the red lead there. I'm going to take this out. Put this on the black lead. Go ahead and turn that off. It should stay the same once we turn it on. I'm going to move my dial to the milliamp. Range. So here we've got the milliamp. When I turn this back on, what's going to happen is the current is going to run from the positive to the negative, which means electron flow runs the opposite because we made a 50-50 bet and we were wrong way back when. So if I turn this on, what I see is there is a current flow of 1.03 milliamps running through this resistor. So for a 1 volt drop across the resistor, there is a 1.03 milliamp current running from the positive to the negative through this resistor. Let's move on to measurement number 2, in which we'll put 2 volts across and then measure the current running through. Note, in these videos I'm going to speed up the reference and just stop to capture the volt and current reading so that we can see our data table populated without having to wait for all the time that it takes to mess around with this video. So enjoy the time sequence and know that I suffer for you. Alright, let's get going. Here we go. We've got 2 volts going through. Break that circuit. .07 amps running through. 3 volts across. .11 milliamps running through the resistor. Let's keep going. 4 volts across. .15 milliamps running through. 5 volts across. 5.1 milliamps running through the resistor. 6 volts across. 6.24 milliamps running through. 7 volts across. 7.29 milliamps running through. 8 volts across, 8.3 milliamps running through. 9 volts across, so the difference between the voltage potential at the red lead and the black lead is 9 volts. Looks like a 9.38 milliamp current running from the red to the black this way. 10 volts across, 10.39 milliamps running through. 11 volts across, 11.39 milliamps running through. 12 volts across, 12.53 milliamps running through. 13 volts across, 13.57 milliamps running through. 14 volts across, 14.62 milliamps running through. 15 volts across, 15.72. And that concludes our measurements for the resistor. We're going to move on in the next video and show these measurements captured in a Excel document, and then we'll graph current versus voltage and see if we can verify Ohm's law for ourselves. See you there.